Hello and welcome to our third installment of trigonometry, 8.4 part 3, trig applications. Today we're going to be seeing how we use trig in the real world, and we're going to be working with elevation and angles of elevation and depression. So angles of elevation and depression are exactly what they sound like. Let's say, for instance, we have a person, and this entire chapter I've been talking about a person's perspective, right? Let's call this person Nick. Nick has a line of sight if he's looking straight forward, right? When he's looking straight forward, and let's say there's a building in front of him, he would probably be looking at a door, let's say something like this, right? And when you're talking about angles of elevation and depression, like I said, it's exactly what it sounds like. If he were to raise his eye level, let's do this in blue, to, let's say, the top of the building, he's changing his eye level from straight forward to the top of the building. That is an angle of elevation. Okay, so that change of eye level from straight forward to the top of the building creates an angle from this original line. Now, there's also an angle of depression. Let's use green. Let's say Nick were to look straight forward again, and instead of looking up, he looks at the very base of the building. Okay, then his eyesight would change, and he'd create an angle of depression. Now be careful here, because most people are very tempted to create this angle here as your angle of depression. That is not true at all. Remember, just like the angle of elevation problem, we have to do it from this particular line of sight. So we create a line from that line of sight downward, and let's call this alpha. That is our angle of depression. I'm going to put the angle a little bit in here. Angle of depression. And this is, like I said, it's the line of sight. It's from this original line of sight. That's how you create these angles of elevation and depression. So that is ultimately the key to all of these problems. Okay. And from there, you could actually calculate a lot of different things, whether it's the height of this building, whether it is how far the building is to the top from you to the top of the building, how far you are from the distance to the building, etc., etc. So let's take a look at an example. So, for instance, let's say we have here, let's call this person Victoria. And if Victoria is outside and she sees a plane, it's a terrible plane, but you get the idea. Plane flying up, way up high. And she sees the plane, and she's looking straight up at the plane. And she's able to determine that the angle of elevation in which she sees the plane is 50 degrees. Okay, there are actually a lot of really cool ways to determine angle of elevation. We could talk about that in class, but let's say she's able to determine that that is a 50-degree angle. And we also know that planes typically fly at 35,000 feet. Okay. What is the distance Victoria is away from this plane? So straight from this plane. Okay. And here we would use some trig. So let's say, from Victoria's perspective, we know, one, this is a right angle, because we're talking about vertically 35,000 feet. So this is x is our hypotenuse. 35,000 feet is our opposite side, and we would use sine to solve this because that's opposite and hypotenuse. So we would say sine of 50 degrees is equal to, opposite is 35,000 over x. And here we would just use some regular trig because we're solving for a side. Multiply both sides by x. X's cancel. Then we get x times sine of 50 is equal to 35,000. Divide both sides by that sine of 50. Sine 50 on the left side cancel out, so we should get x is equal to, and let's do a little bit of math. So we need to do 35,000 divided by sine of 50 degrees, and we should get 445,689.26 feet. Okay, so that's how far Victoria would be from the plane. Now, obviously, this is an exact moment because the plane will be traveling, and that changes, but we could determine that based off of an angle of elevation. Okay, now, what if we took a different example, and this time, let's take a swimming example. Okay, and we're going to draw, let's say, a person is just kind of just coasting or just like hover or just staying afloat, right? They're just treading water. And when they look underwater, they actually see a coral reef. Now, if you ever have the opportunity to see a coral reef, they're actually very, very beautiful. And some really cool fish life actually happens there. But no, that's neither here nor there. Now, let's say we were able to determine, or we could tell, that the coral reef is approximately 20 feet below water. And we also know that swimming to that spot directly above the coral reef is 50 feet. What angle is this particular person looking at the coral reef at? So what is the angle of depression here? Okay, so the angle of depression, remember it's from their line of sight, which is, in this case, it is the water level. Angle of depression is equal to what? And looking at this, we, one, determine that there's a right angle here because we're talking about a vertical distance of 20 feet down to the coral reef. We determine also, this is our hypotenuse because it's opposite of that 90-degree angle. 20 feet is our opposite side. 50 feet is our adjacent side. And we would determine that we would use the tangent function because it works with opposite and adjacent. So here we're going to do tangent of theta is equal to opposite over adjacent, which is 20 over 50. From here, we want the theta by itself, so we're going to use some inverse trig. Remember, we're solving for an angle, so inverse trig is the key. Inverse sine to both sides. And then we take this 20 over 50, we throw that into our parentheses for the trig function. Inverse tan and tan cancel each other out. And we should get theta is equal to, and let's grab our calculator again, inverse tan, or second tan, 20 divided by 50 in your parentheses is equal to, remember this is an angle, so we're going to say, whoa, 21.80 degrees. And this should be an approximation. 21.80 degrees. So that is our angle of depression. Okay? So every problem like this is a case-by-case basis. You have to determine if it's an angle of elevation or depression. If it's given, what's given, what's not given. Are you solving for an angle? Are you solving for a side? Should you use regular trig or inverse trig? So all those factors play, all of those things play a factor into how to solve these problems. I personally love drawing pictures about for these because they help illustrate where your right angle is, where your hypotenuse is, and what you actually need to solve for. Okay, so this is our real world application of trig. If you do have any questions, please don't hesitate to ask, and I'll see you in the next one. Bye.